Okay, student, good morning. First, thank you for complete the test one. I know test one could be more challenging because we have 3 long answer questions. We are working on marking now. Please give me around 2 weeks to complete the marking. I hope the result will be available to students within 2 weeks. All right. Now we are going to continue our discussion on chapter 7, risk and return. So on Tuesday, I hope students you know how to measure the return or expected return, and you know how to measure the risk, that is the standard deviation. But you can see our discussion is just focused on one asset, or you can say one stock. Now we are going to discuss a portfolio or diversification, right? So our next topic is diversification and types of risk. So in the previous discussion, we show you the standard deviation. So we can tell you the standard deviation is the total risk. Now we are going to divide the total risk into, into 2 types of risk, systematic risk and unsystematic risk because of diversification. All right, we are going to show you the detail now. Okay. So diversification, when I see a diversification, I'm thinking portfolio. And the portfolio is a stock like an index, right? For example, S&P 500 or NZX 50. So S&P 500 means 500 stock in the United States. All right. NZX 50 is a 50 stock in New Zealand. So it's a stock index is a good example of portfolio. All right. So let's follow our slide. So the reason is directly related to the fact that return on individual share tend to be riskier than return on index. So stock index, a portfolio, less riskier. That means smaller risk. All right. Individual share will have a higher risk. Right? And you can see our second point. By investing 2 or more assets whose value do not move in the same direction at the same time, an investor can reduce the risk of their collection of investment or portfolio. This is the idea behind the concept of diversification. So here I highlight a few keywords for you. So diversification is to invest your money in 2 or more assets, right? And diversification can reduce the risk, right? So I believe most of students should know this principle. Don't put all your eggs in one basket, right? The idea is diversification. And the diversification has a benefit. The benefit is to reduce the risk. All right. So we will show you how they can reduce the risk. The reason is here, because if we have 2 or more assets, their value do not always move in the same direction. Right. That means one could be up, the other one could be down. Right. Then we can enjoy the benefit of diversification. Let's go to the next slide. So we'll show you the result, the conclusion first. Later, we will discuss why. All right, so you can see this is our result. Expected return on a portfolio is here. So you can see the ER is our expected return portfolio. Right, it is ER1, ER on stock 1, ER2, ER on stock 2. Then we use the weighted average. X1 and the X2, they are the weight, right? So consider total 100%. X1 on stock 1, X2 on stock 2. Of course, the sum of the weight equal to 100%, right? So when we discuss the expected return on a portfolio, the expected return on portfolio is equal to the weighted average, right? But the risk of a portfolio, if we consider risk of portfolio, this is our conclusion. The risk of a portfolio will be lower than the weighted average. This is a diversification benefit, all right? So the reason is here. The prices of two shares in a portfolio will really, if ever, change by the same amount and in the same direction at the same time. All right, because they will not change in the same time. All right, either one could be down, the other one could be up. Therefore, the risk of portfolio is lower than the weighted average. So next slide, we give you an example. So we have two companies, Woolworth and Quanta. So Woolworth is a supermarket company that is downtown. Coast down. So Woolworth, the company, and the Quanta is an airline company, right? So you can see on this graph we have the monthly return for the vertical line and the different day for the horizontal line, right? So you can see return could be positive or negative, right, up and down. And you can see they don't move in the same way or in the same amount. Here, for example, here, you can see one stock is going up, the other one is going down. All right, so they don't move in the same direction or in the same amount. All right. So I have a handwritten note for you, right? So when I consider the two companies, Woolworth is a retail company, right? So then thinking the business cycle, right? So business cycle means we have good year and a bad year. You may refer to your Econ 101 for the discussion, right? For me, business cycle is we have good year and a bad year. So Woolworth is a retail company. For me, this company or the value of the company is less sensitive to the business cycle, right? Because Woolworth, for example, I go for shopping every week. I purchase the grocery. They are necessary goods for my family. So no matter how bad the business cycle is, we still need to buy the grocery. So it's less sensitive to business cycle. On the other hand, Quanta is an airline company. This company will more sensitive to the business cycle, right? For example, if now it's a bad year, I cannot make too much money. Maybe I can reduce my travel, right? Then I don't fly too many. So you can see the difference between the two companies. And if their correlation is small or even negative, then we can enjoy the benefit of diversification because they don't move in the same direction, right? So next slide, we'd like to show you how to calculate the standard deviation of a portfolio. So how to calculate standard deviation of the portfolio. So I hope you remember how to calculate the standard deviation of one stock. So we have several steps. Step one, calculate the deviation, right? Deviation from the expected return. Step two, square deviation to make the deviation positive. Next, weighted average, right? We do the weighted average using the probability, right? Finally, we use the square root because we have square deviation first, then we use the square root to remove the square. So we have standard deviation. I hope you remember the fourth step. To calculate the standard deviation of portfolio, this is our calculation process. So we use the same formula to calculate standard deviation of the portfolio. Step one, compute the portfolio return for each state using the weighted average. So portfolio, we have two or more assets. So we have the weight for each asset. So we calculate weighted return, all right? So we calculate weighted return for our portfolio for each state. Next, compute the expected portfolio return. Right? We do the expected return. So with expected return is a weighted average. For me, it's not difficult. Then we can use the same formula to calculate the variance and the standard deviation, like our individual asset. So I will give you an example, all right? You will understand we can use the same formula to calculate the standard deviation of the portfolio. So this is our example, right? By the way, this example is available on Moodle. I use Excel to do the calculation, all right? So you can see in the example, I consider a portfolio, 50% on stock A, 50% on stock B, all right? So you can see I have two states, boom, bust, like a good year and a bad year, right? And the probability here, I use a simple case of equal probability, right? 0.5, 0.5 for each state. And the stock A, the return, 30% for boom state, negative 10% for bust state. All right, so good year, stock A, 30% positive return. Bad year, negative 10%. All right, so stock A is a normal stock, follow the business cycle, good year and a bad year. Now we consider stock B. Stock B, you can see for boom state, negative 5%, bust state, 25%. Okay, so you can see the stock B is a very special stock. It's an anti-business cycle. You know, that means stock B, boom state, the good year, their return is negative. But bust state, bad year, their return is positive. So anti-business cycle, right? I can give you some example for anti-business cycle, like a gold. Gold price is anti-business cycle, all right? Education company or education industry is anti-business cycle. You know, when we have bad year, people cannot find a job, then they go back to university or school to study. All right, so you can see stock A and the stock B, they are different. In particular, their correlation is negative. So I need to use your statistical knowledge, correlation. So you can see stock A and the stock B, one is up, the other one is down. Right? Their correlation is negative. Now, if we have a portfolio, including A and B, right? First, we calculate portfolio return. We use a weighted average. So portfolio return, we have 50% on A, 50% on B. This is our portfolio return for each state, for boom state and the bust state. All right, so we have the result. Next, we calculate the ER, expected return. So we know we can apply weighted average on expected return, and this is the result, right? So we have 0.5, the probability 0.5 on 12.5%, 0.5 on 7.5%. Then we have the result, all right? And here I will decide the number. You can see A, B, and the portfolio, they have the same return. All right, now we discuss the sigma or standard deviation of the portfolio. So you can see the 4-step process. Step 1, deviation from ER. So our ER for the portfolio is 10%. That means 0.1. So this is the deviation from ER. Next, square deviation, right? Next, weighted average. B4 and the B5, they are our probability, weighted average. Finally, square root, all right? So we have the standard deviation of our portfolio. And you can see the number is very small, just 3%. So you can see the result. This is our conclusion. Diversification. So we have a portfolio, we have diversification. And the diversification or the portfolio we can reduce the portfolio risk. You can see the risk from star A 20%, star B 15%, portfolio is just 3%. So we can reduce portfolio risk, but without reducing portfolio return. So portfolio return is the same, right? But we can reduce the risk. So we always say there is no free lunch, but it's a very special case. In finance, we have free lunch. It's a free lunch in finance, diversification. All right, we can reduce the risk without reducing the portfolio return. All right, so it's a key concept in finance. All right, and it's very important. To let you remember this concept, again, I like to use an example and make a joke on that. So for me, marriage is a portfolio. Before marriage, one person to make money, one asset. After marriage, two people to make asset, right? Portfolio, right? The portfolio. And the difference, it could be beneficial, right? So I remember diversification. I remember the difference. So I am a lecturer on campus. My wife, she was a flight attendant in an airline company. So you can see it's a very good portfolio, right? However, after the marriage, she decided to quit her job because her goal is not to make money. Her goal is to spend my money. So now I don't have portfolio. I only have one asset. She is not an asset anymore. She become my liability. Just make a joke. Don't tell my wife. All right. So I hope you remember the key concept. Diversification and difference or negative correlation. The lower correlation, even negative correlation, the better diversification effect. All right. So to make a comparison, now I have two spell sheets. We make a comparison. You can see why difference is the key. So the first Excel sheet is our previous example, A and B, right? They have a negative correlation. But now I consider another portfolio, A and C. So you can see A and C, their correlation is positive. So that means they will go up and down at the same time. All right. So now we consider the two portfolio. The first portfolio, you can see the sigma or standard deviation of the portfolio is very small, just 3%. But for our second portfolio, the sigma is 18%. So if you have portfolio, but they are the same, for example, here, if they are the asset from the same industry, you don't have diversification benefit. All right, so this is our conclusion. Portfolio diversification is an investment in several different asset classes or sectors. All right, diversification is not just holding a lot of assets. If you have a lot of assets, but they are from the same industry or same sector, you don't have diversification benefit, right? As I show you here, okay? So let me use my handwritten note to make a conclusion on this slide. Right? So portfolio one, we have 50% on A and 50% on B. And A and B, their correlation is negative. And you can see portfolio return is weighted average, but its standard deviation or sigma is much, much smaller than weighted average. The key is here, negative correlation. All right. On the other hand, portfolio two, A and C, their correlation is positive. Their expected return is weighted average, and their portfolio standard deviation is also the weighted average. All right. So no benefit by the portfolio. All right. If the correlation is positive. So here I have a note. It's an issue in finance. Safe haven asset against stock risk, right? So in finance, we have the safe haven asset. So safe haven asset means the correlation with the stock is negative, right? When stock market is going down, safe haven asset is going up, all right? Then we can have the diversification benefit. Here I give you example like a gold or government bond, all right? They are good example for safe haven asset. All right. So after our test one, we have a good assignment. So in a good assignment, I will have a question about the diversification. I hope students you can understand what are the safe haven asset, and all right, and why they are safe haven asset against the stock risk. The key is correlation. All right. And in our final test, test 2, I will also have a calculation about portfolio. So in our example lecture, we use the 2-step example in the equal way. But in our test 2, I might consider three-step system. That means we not only have good year or bad year, we have good year, normal year, and a bad year. Right? We have 3 steps, but the concept is the same. Right? Please practice the Excel file. Right? You can extend the 2-step to 3-step. So now we are going to next slide. So on this table, we show you the number of stock portfolio versus standard deviation of the portfolio return. Okay, so we know portfolio can reduce the risk. So we use the real-life data, and this is our final result. We use the data of NYSE, New York Stock Exchange. NYSE include 2,000 stocks in the NYSE, right? So we calculate standard deviation of the portfolio return, right? And we increase the number of stock in the portfolio. And you can see when the number of stock in the portfolio is going up, the standard deviation of portfolio is going down, but it will not go down to 0, right? No, it will not go down to 0. Therefore, we have this slide, the limits of diversification. So this is our conclusion. So you can see the vertical line is the total portfolio risk. That means standard deviation of the portfolio, right? And the horizontal line is our number of assets. So you can see when we increase the number of assets, the standard deviation of the portfolio will go down, but will not go down to 0. There's a limit, right? Limit of diversification. So we can divide our total risk into 2 types of risk. This is non-diversifiable or systematic risk, and this is diversifiable or unsystematic risk or unique risk. All right. So let me show you my handwritten note. This is a key conclusion or key principle in finance. So this principle is by Professor Mark Weiss. He won the Nobel Prize because of this principle, the portfolio theory, right? He won the Nobel Prize in 1990. And he tells us the total risk of a portfolio, I use a sigma P for the total risk of portfolio. We can divide the total risk into systematic risk and unsystematic risk, all right? Systematic risk is a constant, it will not change. But unsystematic risk will go down when we have a portfolio. That means when the number of assets go up, the unsystematic risk will go down. All right. So then we have 2 types of risk. One is the systematic risk. The other one is unsystematic risk. All right. So another note is here. Stock price. So think about the stock price of a company. the triangle mean change. The change in stock price could be due to two factors. One is by the market. If the market is down, the individual company will go down as well. This is the systematic risk. Systematic risk will affect all the company in the market. Therefore, we cannot reduce the systematic risk. All right. However, the other risk is unsystematic risk. Unsystematic risk is the change in stock price is due to the firm itself or the company itself. This is unsystematic risk. All right. And our diversification can reduce the unsystematic risk. All right. So this is our key conclusion. And next slide, we review or address the conclusion again. So the limits of diversification. The standard deviation of a portfolio does not approach zero, right? Because we assuming that the variation in asset return do not completely cancel each other because we have systematic risk, right? The risk can be diversified away. It's called diversifiable or unsystematic risk or unique risk. On the other hand, the risk that cannot be diversified away is called systematic risk or non-diversifiable risk. Okay, so let me go back to the previous slide. So for me, this graph is the key. All right, so diversification can reduce the portfolio risk, but portfolio risk will not go to zero. All right, we still have systematic risk. All right. So students, you might ask me, how can we reduce the systematic risk? Portfolio can reduce unsystematic risk. How to reduce the systematic risk? In finance, we have another issue, hedge. We can use a hedge to reduce systematic risk, but we don't have time to discuss further. If you are interested in finance, we have 302. You will understand the issue of hedge further. All right, so let's stop here. Okay, so next slide. Why systematic risk is all that matter? Right. So the first point, the objective of diversification is to eliminate the variation in return that are unique and to individual assets. So with complete diversification, all the ununique risk is eliminated from the portfolio. Right. So an investor with a diversified portfolio still faces systematic risk. However, we now turn our attention to the form of risk. Let me use my handwritten note to show our conclusion in a simple way. So at the beginning of the class, we told you the RR relation, higher risk, higher return for higher risk. But now we like to modify our relation. That means the risk is for risk, systematic risk only, right? Only systematic risk will receive a return, right? Unsystematic risk will not receive the return, right? Because unsystematic risk can be diversified away by portfolio, right? So it will not receive the return as a compensation, all right? So next slide, we tell you because of the competition, right? Because of market competition, unsystematic risk is unnecessary, right? So investor, professional investor, they know they need to do the diversification and that they can reduce unsystematic risk without reducing return. So because of the competition, only systematic risk is rewarded. All right, so this is our conclusion. So next slide, how to measure the systematic risk. the method is regression. So you can see we have the data. So we have the return on individual company, for example, Wolf. Then we have the return on the market index, for example, S&P 500. Then the dot denote the observation or sample. So let me show you my handwritten note. So you run a regression. You have RI is the individual stock return. RM is a market return. So you run the regression. This is our regression. I hope you remember the regression in your statistic courses, right? So alpha and beta. Beta is the measure of systematic risk. So beta is amount of the market risk. That means when the change in RM is 1%, change in RI is beta percent. All right. If beta is 1, that means the same market risk. Is higher than 1, high market risk. Lower than 1, low market risk. All right. So I give you 2 example company. So we don't need to run the regression. You can find the beta of the company using the Yahoo Finance. So I just have the data from Yahoo Finance. For example, Coca-Cola is a beta is 0.16, smaller than 1. And Apple's beta is 1.4, higher than 1. Right? So that means Apple has a higher systematic risk. Coca-Cola, lower systematic risk. The result makes sense to me. Coca-Cola is a grocery. It's a necessary good, right? So you can see the systematic risk is lower. On the other hand, Apple, higher systematic risk, right? Or higher market risk. Right? That means when we don't have money, we don't buy the iPhone, the new iPhone, right? Because it's very expensive. Okay, we finished the discussion on this topic. We spend more time on this topic because this topic is very important. So let me review some key concepts for you. 1, portfolio weight is a percentage investment in each asset. Portfolio expected return is weighted average. Portfolio standard deviation will be lower than weighted average. So portfolio can reduce the risk, in particular, reduce unsystematic risk. So total risk includes systematic risk, unsystematic risk, right? So when securities are combined in portfolio, their unsystematic risk tend to be canceled out. Systematic risk cannot be eliminated by diversification. To eliminate systematic risk, hedge. But we don't have time to discuss hedge. Just let you know, we have another method. So systematic risk principle, the reward for barren risk depends only on systematic risk of the investment. All right. And to measure the systematic risk, we use the beta. All right. Beta is a measurement of systematic risk. All right, so we like to go to the next slide, CAPM model, CAPM. So the component for taking on risk, or in particular systematic risk, which vary with the risk of the asset, is added to the risk-free rate of return to get an estimate of expected rate of return for an asset. So this is our CAPM model, right? ER of stock I is RF, risk-free rate, plus compensation for taking the risk, right? So we know we take the risk, we have compensation. Here, the risk is systematic risk. We take systematic risk, then we have compensation. In addition to the compensation for taking risk, we also have RF, risk-free rate. So even risk is 0, investors still require return. The reason? Inflation. So risk-free rate reflects the inflation. So we have this result, right? Next, compensation per unit of systematic risk. So systematic risk, that means the market risk. So we use the ER minus RF. This is the market risk premium. So premium means additional return, right? Additional return for taking market risk. So ERM minus RF, this is our market risk premium. Premium is additional return for taking risk. So now altogether, ERI will be RF plus beta. Beta is the amount of systematic risk times MRP. MRP is our market risk premium. All right. So let me show you my handwritten note. Let's summarize or address the key point. So capital model, this is a format of capital model. Capital asset pricing model. Professor Sharp developed this model. And this model is important because it quantifies the RR relation. All right. And Professor Sharp won the Nobel Prize because of this model. Right. So how to measure, how to quantify the RR relation? We have three components. One, RF, risk-free rate. Risk-free rate reflect time preference or inflation. Right. Second, MRP, market risk premium. When you take market risk, you have the additional return, MRP. Beta is the amount of the market risk. Right. Altogether, this is our capital model. All right. Although you think the model is simple, but it's very important because Professor Sharp won the Nobel Prize because of this model. Right. So this model quantifies the RR relation. Right. So first, our focus is market risk. All right, or systematic risk only, because only systematic risk can receive the return. And we use the beta to measure the market risk. All right. And then we have RF, risk-free rate. Even risk is zero, we still have return or risk-free rate. So next slide, we show you the security market line. It's a terminology in finance. So security market line is based on our capital model. So I copy the capital model here. So you can see the vertical line is our ERI. The horizontal line is our beta, or the amount of the market risk. So when beta is zero, beta no systematic risk, zero, we still have return. The return is RF. And when beta is going up, higher market risk, higher ER. All right, so you have the security market line. Okay, next slide. So in the capital model, we show you how to calculate the expected return. All right, expected return or expected total return for the portfolio. It's based on the beta. So again, I copy the capital model for you. So our expected return based on the beta, but it's not equal to actual total return. The actual return is a change in price plus the cash flow or the income component divided by initial price. This is our actual return, right? And they will not be the same, okay? Because expected return is based on the model. The actual return is based on the market data. All right, they will not be the same. So next slide, we show you the portfolio beta. All right, so beta is a systematic risk. We know how to calculate the systematic risk for individual stock. Remember the regression. So you collect the data and run the regression. You have the beta. How about portfolio beta? If we have portfolio, how to calculate the portfolio beta? The idea is simple. We can use weighted average. So let's consider the portfolio. We have N stock, stock 1, 2, 3, 4 to N. Then we can apply the weighted average. X1, X2, they are weight, right? So we can apply the weighted average. So again, we can apply the KPM model. So if we have the portfolio beta, then we can apply the KPM model on portfolio. So let me give you my handwritten note to address our key conclusion. So when I think about portfolio, first, portfolio ER, expected return is weighted average, right? Portfolio standard deviation will be lower than weighted average because of unsystematic risk will be diversified away. All right, so portfolio standard deviation is lower than weighted average. But the beta, portfolio beta is weighted average. You might ask me why? Why we can use a weighted average? You need to remember the definition of beta. Beta is systematic risk. And the systematic risk cannot be diversified away. All right. Therefore, we can apply weighted average on portfolio beta. All right. So this is our key conclusion, right? ER of portfolio weighted average, beta of portfolio weighted average, but standard deviation of portfolio lower than weighted average. So here is our example for calculation. So we have the portfolio including 4 stocks. You have the weight, right? You can see unequal weight and their beta, right? So beta higher than 1, high systematic risk. Beta is lower than 1, low systematic risk. What is the portfolio beta? The calculation is here, weighted average, right? So you might ask why we can apply weighted average on portfolio beta, because beta is systematic risk. Diversification cannot affect our systematic risk. So we can apply the weighted average. Okay. Okay, we finished the discussion of the lecture. So now we review the key concept for you. So this topic is to discuss the KPM model. It's the most important finance model in finance model. So I know the beta coefficient. Beta is measure how much systematic risk an asset has relative to the asset of the average risk. So beta is a measure of systematic risk. Then I have this KPM model. So ER, expected return of a stock I, is risk-free rate plus beta times market risk premium. All right, this is our KPM model. In the portfolio beta, we can apply the weighted average on portfolio beta. The reason beta is systematic risk and cannot be canceled out by portfolio. Okay. All right. We finished today's lecture. Before we go, the attendance recordings, I will show you the QR code. Hey, student, you can use the QR code to do your attendance recording today. Thank you for coming. Have a nice weekend. Right. Online student, please use the QR code to record your attendance.